Hey, what's going on, guys? Let's do this problem right here. This question is asking to find the radius and intervals of convergence, and let's see how we can do this. The first thing we have to do is we have to take the ratio test here, and the ratio test is going to be limit n approaches infinity an plus 1 over a, right? And here, everywhere, wherever we have n, we are going to just add one more to that. So here we are going to have limit n approaches infinity x minus 2 power n plus 1, and in the denominator we are going to have ln n plus 5, and then because n plus 4 plus 1, that's how we got n plus 5, right? And then we have to divide this one by an, that's original function. That is same as multiplying this by reciprocal of this one, right? So that is same as multiplying this one by ln n plus 4 over x minus 2 power n. And here you can notice that you can cancel these two, x minus 2 power n, x minus 2 power n, and then x minus 2 power 1 will remain, and then we have these two will remain, right? Since we are only dealing with n right here, we can move x minus 2 to the front. So here we are going to have x minus 2 in the front, absolute value, limit n approaches infinity, ln n plus 4 over ln n plus 5. And if you notice, this is infinity over infinity because we have n, and if you substitute n infinity right here, this is going to be infinity over infinity. So we have to use L'Hopital rule. Now let's go ahead and use the L'Hopital rule right here. And if we use L'Hopital rule for this one, this is going to be, derivative of this one is going to be 1 over n plus 4, 1 over n plus 4 over derivative, so limit n approaches infinity, 1 over n plus 4, and then we have 1 over n plus 5, and then we have to just flip it, right? So we can continue this one. This is going to be limit n approaches infinity, n plus 5 over n plus 4. Since we have the same power, n power 1, n power 1, the ratio is going to be the limit. Ratio is 1 over 1, right? That's going to be just 1. Now limit for this one is 1, and we have x minus 2. Therefore we can say the endpoint is going to be between x minus 2 is going to be less than 1. So the endpoint is going to be x minus 2 is less than 1 and negative 1. Now if you move this negative 2 to this side, that's going to be positive 1, minus 1 plus 2, positive 1, x, and 1 plus 2, that's going to be 3. So this is our endpoints. Now we have to find whether to include this endpoint or not. To find that, what we do, we have to find whether this converges or diverges. If it converges, we have to include. If it diverges, we shouldn't, we put it in open bracket. Now let's go ahead and find for 1. To find that one, what we do, we plug this one in for the x value and find whether that series converges or not. Now let's go ahead and plug this one right here. So if you plug this one for this one, this is going to become negative 1 power n, right? Because 1 minus 2, that's going to be negative 1, negative 1 power n. So we are going to have n is equal to 1 to infinity, negative 1 power n over ln n plus 4, right? And you can see this is an alternating series because we have negative 1 power n. So this is an alternating series. So whenever we have an alternating series, what we do is we take the bn value. Bn value is everything except this negative 1. So that's going to be just 1 over ln n plus 4, and check whether that limit is 0 and also it is decreasing. If it satisfies both of them, it means that series converges. If it fails to satisfy one of them, it means that series diverges. Now let's go ahead and take the limit first. Limit n approaches infinity 1 over ln n plus 4, and you can see this is 1 over infinity, so this is definitely equal to 0. So this satisfies one of the convergent tests. Now let's go ahead and find whether this is decreasing. Now this is 1. Let's take this one, 1 over ln n plus 4, and you can see as the n value increase, this ln value is going to increase. So as the denominator increase, the whole value is going to be decreasing, right? Because we are dividing by bigger values. So this is definitely decreasing. So this satisfies both of the convergence tests. So this is a convergent alternating series. Now therefore we have to include this one in the interval, so this is going to be in close bracket. Now we have to find whether this 3 converges or diverges. To find that, again we plug this one for x value, so that's going to be 3 minus 2, that's going to be 1, right? So 1 over ln n plus 4, that's what we are going to have. Now let's get rid of this part, we need space. Okay, let's continue this one right here. So here we are going to, if you substitute 3, this is going to be just 1. So we are going to have n is equal to 1 to infinity 1 over ln n plus 4, because 1 power n is going to be just 1, and then ln n plus 4. Let's see how we can find it. So whenever you see something like n, something in the denominator, you can compare with p series. Now how can we compare this one? And you know that we have, if we have ln n plus 4, and we can compare this one with n plus 4 and see what happens. And you can see that n plus 4 increases much faster than ln n plus 4. So this is definitely less than n plus 4. And if it's less than n plus 4, the reciprocal, 1 over it is going to be opposite. Like we are dividing this one by smaller number, so this is going to be bigger, right? And this is, we are dividing this by a bigger number, this is going to be smaller. So this is smaller than this. How this is going to help us? Now if you can prove this one divergence, and if this is value is bigger than this is so going to be definitely divergent, right? Now all we have to do is we have to prove this one diverges. To prove this one, what we do, we take the dominant value, that is 1 over n, and see whether that one diverges or converges. Now 1 over n is a divergent p series because we have n power 1, and if we have n power 1 or less, that is divergent p series. So this is a divergent p series, and to prove this one also divergent, what we do, we take the limit comparison test. Limit comparison test says if you divide this one with its dominant value, and if you get a positive finite number, it means both the series will behave in the same way. So let's see whether we can get a positive finite number. Now let's go ahead and do that. Limit n approaches infinity, and here we have 1 over n plus 4, and we have to divide this one by this. That is same as multiplying by n over 1, right? So this is going to be, and if you can see, this is going to be equal to limit n approaches infinity 1 over, it's actually n over n plus 4, and we have same power, n power 1, n power 1, so the ratio is going to be the limit. So the limit is going to be 1, and we are getting positive finite number. So definitely, since this is divergent series, definitely this one also divergent, right? So if this is divergent and this is bigger than this one definitely divergent. So if this series is divergent, we shouldn't include these 3 in this intervals of convergence. So this is going to be This is a divergence, so we have to put this one in open bracket. Now this is going to be our interval of convergence. Then now the next question is, what is the radius of convergence? To find the radius of convergence, we just have to find the length of this interval. To find that, what we do, we take this value, like 3 minus 1 divided by 2, and that's going to be 2 over 2. So the radius of convergence is going to be just 1. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.